So, hi to everyone. MEM School of Engineering, Department of Mechanical Engineering, online class 2. Subject code ME8791, subject title Mechatronics, unit number 1, chapter 2. So, myself, Saravanan, Assistant Professor, Mechatronics. So, this is the course objective and outcome of Mechatronics. So, this is the syllabus. So, now today we are going to see about unit 1, chapter 2, that is textbook reference. So, unit 1. There is chapter 2. So last class in chapter 1 we discussed about what is mechatronics, so what is the need for mechatronics, so what are the class types of mechatronics, where we are using, what are the applications, so then what are the main areas used in mechatronics systems like that. Okay, today we are going to see about emerging areas of mechatronics as well as classification of mechatronics systems. So first we need to know what are the elements of mechatronics. So mechatronics having uh, already we know that electronics, mechanical, and software engineering, control system engineering like that they have. Okay, first we need to know what is mechanical system. So mechanical system consists of system model and dynamic response. That is, it is manufactured by the uh, mechanical elements like actuators and sensors. So this is the first one, mechanical system. So that is example for actuator is solenoids, voice pulse, DC motors, stepper motor, servo motor, hydraulics and pneumatics. For sensors, switches, potentiometers, photoelectrics, digital encoder, strain gauge, thermocouple, accelerometer, and MEMS. So these are the mechanical system used. Then input signal conditioning and interfacing. Okay, for input signal, most of the sensors uh, gave the output of normal voltage. That is, it will produce the output analog signal only. But processor cannot process the analog signal. Okay, because of over noise signal. So we need to convert the analog signal into digital. So we are using analog to digital converter and digital to digital converter. So for the output of sensor will be small signal. Okay, we need to amplify and filter of the input signal. So we need to use discrete circuits like filters, like amplifiers. This is the input signal conditioning and interfacing unit. So next one is digital control architecture. So this is the processing unit. Okay, most of the systems having a processor, they have a separate controller like that they have. Okay, so basic examples are logic circuit, microcontroller, SPC, program logic controller, PLC, sequencing and timing, so logical and arithmetic, control algorithms, communication. These are the digital control architecture. So this unit control the total manufacturing process for the development of the perfect devices, perfect products. Okay, so next one is output signal conditioning and interfacing. Okay, so already I told processor only process the digital signals, but mechanical system not accept the digital signals. Okay, we need to convert digital signals into analog. Okay, so that we are using digital to analog converter as well as digital to digital converters. Okay, same as actuators does not work for 0 to 5 volt like that. Okay, we need to give more voltage, so we need to use amplifiers, PWM for different time period inputs, then power transistors, power operational amplifier for higher gain of output. So this is produce the output signal conditioning and the interfacing. So this will given to the actuator for the next process, for the next process. Okay. Then as well as the output signal conditioning is this goes to the graphical displays. So graphical displays are LEDs, LED, LCDs, digital display as CRTs. Okay, for showing the what is the status of the signal, what is the status of the manufacturing process, what is the status of the system. If there is any failure like that, it will indicate in the graphical displays. So these are the elements available in the mechatronics. That is mechanical systems, input signal conditioning and interfacing, digital control architectures, then output signal conditioning and interfacing, then graphical display. Okay. So next one, emerging areas of mechatronics. So nowadays, what are the areas available in the mechatronic system? Okay, already we know that design and manufacturing like that we discussed. Okay, now we are going to see about products and systems in manufacturing. Mechatronics mainly used in the product and the system in manufacturing. So that is, we are going to product the some we are going to manufacture some products as well as we are going to create some mechatronic system. Okay. So mechatronics has a variety of applications as products and a system in the area of manufacturing automation. So some of these applications are as follows. First one is computer numerical control machines, that is CNC. Second one is tool monitoring system, simply called a TMS. Third one will be advanced manufacturing system, that is AMS. In AMS, we have two types: flexible manufacturing system as well as computer integrated manufacturing. Then industrial robots, automation instruction systems, that is machine vision systems. So finally, we have automatic packaging system. These are the emerging areas of mechatronic systems. So first one, we will see one by one. So first one is computer numerical control, that is CNC. So CNC is a machine. It's the best and the basic example of application of mechatronics in manufacturing automation. The efficient operation of conventional machine tools such as lathe, milling machines, drilling machines is dependent on the operator skill and training. Okay, but CNC is an automated machine. Okay, it will know the if you code something, so it will produce something. Okay, so it will not depend on the operator skill and training. The CNCs are all depend on the programming and processor. Okay, so I'll say a lot of time is consumed in work part setting, tool setting, and controlling the processor parameter of efficient, sorry, conventional machine. Okay, thus conventional machining is slow and expensive to meet the challenges of frequently changing product, part shape, and size. Okay, in CNC, tools are integrated part of computer aided machines, that is CAD. Tools are the integrated part of CAM, that is computer aided manufacturing or computer integrated manufacturing system. So CNC means operating machine tool by a series of coded instructions. Series of coded instructions consist of numbers, letters of the alphabets and symbols which the machine control units can understand. That is MCU. Most of the machine control unit is a processor or microcontroller or PLC like that. So we need to write the program according to whether the machine know or not like that. We need to program the CNC machine. So these instructions are converted into electrical pulses of current which the machine's motor and control follow to carry out machining operations on a workspace. Okay, this is CNC. So this is the best example for conventional milling machine as well as CNC machine. So in this machine tool, here all the connections are done by the manual process. Okay, some operator come and open the lever or close the lever like that. We need to fix the material in the bed. Okay, here so there is no process, only on off switch. Okay, so if someone any operator will come and on the switch means the microprocessor will take the process. So what is the step by step process? So what are the functions we need to know? Okay, so automatically the levers and um, small robots links are define the material in the bed, so as well as grinding the material in the some what we need to convert in the format. So like that they are using CNC. Okay, that is it is having automatic tooling facility. So automating movement of spindle zone Z axis. So automatic movement of work table in XY axis. This is the door on off, that is safety for operator. It is the CNC machine tool. Okay. So next one, tool monitoring system. So for a uninterrupted manufacturing, we need to define the tool uh, tool monitoring. Okay, because of if you manufacture some drill bits means we need to perfectly we need to drill the bits. Okay, then we need to find out the what are the uh, we need to find out the uninterrupted machining is one of the challenge in front of manufacturers to meet the production goals and the customer satisfaction in terms of product quality. To wear is a tool wear is a critical factor which affects the productivity of a machining operation. The complete automation of a machining process realized when there is a successful prediction of tool that is stayed during the course of machining operation. The mechatronics based cutting tool wear condition monitoring system is an integral part of automated tool rooms and unmanned factories. These systems predict the tool wear and give alarm to the system operator to prevent any damage to the machine tool and workpiece. Therefore, it is essential to know how the mechatronics is helping in monitoring the tool wear. So tool wear can be observed in a variety of ways. These can be classified into two group tables. So that is direct method tool monitoring system. Another one is indirect method tool monitoring system. So direct method means that is electrical resistance, optical measurements, machining hours, contact sensing are calculated by the direct method. In indirect method, they are using torque, power, temperature, vibration, acoustic emissions, cutting forces, and strain measurements are calculated by the indirect method. So direct methods deal with the application of various sensing and measurement instrumentation. A direct method deals with the application of various sensing and measurement instruments such as microscope, machine or camera vision, radioactive techniques to measure the tool wear. So they are called as offline tool monitoring system. Indirect method predicts the condition of the cutting tool by analyzing the relationship between cutting conditions and the response of machining process as a measurable quantity through sensor signal. So outputs such as force, acoustic emission, vibration or current are calculated by the indirect method. So in this is the diagram for indirect method calculation. This one direct method for calculate the some parameters. Okay, steps followed in the indirect tool monitoring system. That is data collection in terms of signals from sensors such as cutting, force, vibration, temperature, acoustic emission, motor current like that. So data collected by the some uh, sensors. So study and analysis of signal and the extraction of features. A third step is tool wear pattern recognized using AI techniques such as fuzzy logic, neural network, classification of patterns, and the estimation of tool wear. Okay. So fourth one is development of automatic or adaptive systems to control the machining process based on step two. Okay, these are so there are two methods in the direct and indirect method of tool monitoring system. So next one is advanced manufacturing system. So that is AMS, advanced manufacturing system having first one flexible manufacturing system. Advanced manufacturing system having flexible manufacturing system. The manufacturer production concept has moved away from the mass to small batch type of production. So batch production offers more flexibility in product manufacturing. To cater this need, flexible manufacturing system have been evolved. The FMS combines microelectronics and mechanical engineering to bring the economics of the scale to batch work. Okay. A central online computer controls the machine tool, other workstation, and the transfer of components and tooling. The computer also provides monitor and information control. This combination of flexibility and overall control makes possible the production of a wide range of products in small numbers. Okay. So FMS is a manufacturing cell or a system. It is consists of workstation, material handling equipment, tool system, and control systems. Okay, that is CNC workstation having CNC machine tools, assembly equipment, measuring equipment, washing stations like that. The workstation having material handling equipment having load unload stations, robotics, automated guided vehicles, automated storage and retrieval systems like that. Material handling having tool systems. So tool system having tool setting stations, tool transport systems. The next one is control system having monitoring equipment and network. So these are the works for FMS. Then characteristics of FMS, that is FMS solves the mid-parity and mid-volume production problem for which neither the high production rate transfer lines nor the high flexible standalone CNC machines are suitable. So several types of a defined mix can be processed simultaneously. Okay. So tool change over time is negligible. Okay. So part handling from machine to machine is easier and faster due to employment of computer controlled material handling system. Next one, benefits of an FMS. This is the benefits. So first one is flexibility to change part variety, high productivity, high machine utilization, less rejections, high product quality, so reduced working process and inventory, better control over production, so just-in-time manufacturing, minimally manned operation, easier to expense. These are the benefits of FMS. So next one, CIM, that is computer integrated manufacturing. Okay, that is designing, analyzing, testing, manufacturing, packaging, quality control are involved in the life cycle of a product or a system. So application of principles of automation to each of these activities enhance the productivity only at the individual level. These are termed as islands of automation. Okay. So integrating all these islands of automation into a single system enhance the overall productivity. Okay, such a system called computer integrated manufacturing. Okay, that is simply we can say CIM is the integration of the total manufacturing enterprise through the use of integrated system and data communications coupled with new managerial philosophies that improves organizational and personal efficiency. Next, industrial robot. This is the uh, main unit in the manufacturing process because for handling the material, for drilling or welding, grinding something, some application done by the industrial robot, painting like that. Industrial robots are generally general purpose reprogrammable machines which respond to the sensory signals received from the system environment. So based on these signals, robots carry out programmed work or activity. Okay. So first one is part handling, part processing. So generally part handling is recognizing, sorting, separating the parts, picking and placing the part, next to loading and unloading. So like that part handling. Then part processing they are using used for routing, drilling, flame cutting, coating, painting, polishing, heat treatment, dip coating like that they are used in the industrial robots. So product building. This involves development and building of various products such as electrical motors, car bodies, solenoids, circuit boards. Okay. So next one, automatic quality control and inspection system. That is supply of a good quality product or a system to the market is the basic aim of the manufacturing industry. The product should satisfy the needs of customers and it must be reliable. To achieve this important product parameter during the short lead time is really a challenge to the manufacturing industry. This can be achieved by the building up the quality right from the product design stage and maintaining the standards during the production stages till the product delivery to the market. Okay, this is the automatic quality control. Okay. A number of sensors and systems have been developed that can monitor quality continuously with or without the assistance of the operator. These technologies include various sensors and data acquisition systems, machine vision systems, metrology instruments such as coordinate measuring machine, optical profilometer, digital calibers, and screw cages like this. Okay, so I hope we all know about the elements of manufacturing and the emerging area of emerging area of mechatronics. Okay, these are the concepts. Okay, okay. Thank you all. We will see in the next class.